So this note card is number 60, and the title is Simplifying Radicals. Simplifying radicals. And a radical, don't let that word throw you off. It's just another name for that symbol. And of course, this symbol means take the square root. So sometimes we call it a square root. Sometimes we call it a radical. If I call it a square root, everybody knows what I'm talking about. Sometimes if I say radical, it messes with it. So that's what a radical is. So first we're going to write down the perfect squares. And a perfect square, you don't have to write down this definition. A perfect square is a number that when you take the square root of it, it comes out nice, meaning it doesn't have any decimals or anything. So for example, 25 is a perfect square because when you take the square root of 25, it's just 5. But 14 is not a perfect square because when you take the square root of 14, it's 3.6 yada, yada, yada. It goes on forever. So it's not a nice number. So perfect square is you take the square root of it, comes out nice as a nice whole number. So here's the first few of them. Oops, I skipped 16. So 1, 4, 9, 16, 25. That's the first few perfect squares. So again, 9 is a perfect square because when you square root it, it comes out to 3. So what's the next one after 25? 36. 36, good, because that's 6 times 6. And then 49, because that's 7 times 7. And then 8 times 8 is 64. 9 times 9 is 81. So we could be here for a long time listing out perfect squares. Because the next one is 12 times 12, and then 13 times 13, and 14 times 14. So the list goes on forever. I know it seems like sometimes we're here forever. But if we listed all the perfect squares, we would literally be here forever. Because it goes on forever. Again, this class seems like forever. I know how that is, but this would really be forever. All right, so that's just a list of some of the numbers that, if you take the square root of it, comes out nice. So we're going to use this list in what we're doing today. So here are the steps for simplifying radicals. So the first step is rewrite the square root as 2 square roots multiplied. Rewrite the radical as 2 radicals multiplied. So I'm just going to do an example problem over here, but you don't have to write this one down. So let's say we have got the square root of 24. So what are 2 numbers that multiply to be 24? Yeah, 6 times 4, good. There are other options. What else multiplies to be 24? Yeah, man. 12 times 2, awesome. And I guess you could do 1 times 24. Okay, so here's 2 ways to follow the first step. The first step said rewrite the radical as 2 radicals multiplied. So that's what we did here and here. doesn't, for now, either one is following step number 1. Okay, then step 2 is find the square root of the perfect square. Find the square root of the perfect square. All right, so when you take the square root of 2, what do you get? A decimal, yeah. So if you have a calculator, you could type it in, square root of 2. I think it's 1.414, yada, yada, yada. It fills up the entire screen. So that answer is not very nice. Same thing with the square root of 12. It's not a very nice answer. Square root of 6, not very good. Here's a good one, though, square root of 4. So I said either of these were an option for step number 1, but this is better because this one comes out nice. And over here, neither of them come out nice. So your goal on step number 1 is to split it up, but split it up into at least one of them that's going to come out good. All right, so the square root of 4 is 2, obviously. So I'm going to write 2 underneath that because that's the answer. But the square root of 6 is a decimal. So I'm not going to figure out that answer. So since I'm not figuring it out, I still have to write the radical sign. Now people sometimes accidentally drop the radical sign. So let me just explain what's going on here. If you did this problem, 6 minus 4, you would get 2. So here's the point I'm trying to make. This is obviously not right. The point I'm trying to make is the subtraction sign is a set of instructions. So once you follow those instructions, you shouldn't write it anymore. That's why that should be gone. You all know it should be gone because you know that subtraction tells you to do something. And once you do it, you don't need to write it. So same thing with this symbol here. That symbol is a set of instructions. So it would be silly for me to continue writing the instructions there because I've already done it. So that's why the radical symbol is gone there. But here I haven't followed the instructions yet. So that's why I had to keep it for that one. So everybody knows, because you've been using the subtraction sign since 2nd grade, everybody knows that the subtraction sign is a set of instructions. But this symbol, as a set of instructions, it's newer for you, so you're not quite as solid on that. So that's why I'm emphasizing this. You follow the instructions, then it's gone. You didn't follow the instructions, so it's still there. Okay, so that's step 2, find the square root of the perfect square. And then step 3 is leave the non-perfect square under the radical. So that's it for note card 60. If you don't already have a sheet of paper out, please get one out. I do have a joke today, though. A lady went to the local dog pound because she was going to get a new dog. And she came up to this one cage, and there was this dog that looked sort of cute, so she was intrigued. But then after a little bit, the dog went, "Roof!" 12:33. She thought that was really strange. So she decided to walk on and look at some other dogs. And so she was down the corridor a little bit, and then just a short time later, she heard, "Roof!" 12:34. She said, "This is really weird." So she went to the front counter and said, "I'm looking for a new dog. One kind of looks cute, but there's this dog that just keeps barking and then saying numbers." And they said, "Oh, you mean the watchdog?" There's a watchdog because it was telling the time, right? I don't understand why you're not laughing. It's hilarious. You guys, you need to wake up because when I tell my hilarious jokes, you should be laughing. When I do my great math, you should also be very happy about that as well. I'm kidding. I'm definitely kidding on that one. Anyway, today's worksheet is simplifying radicals. I found that if people are really not laughing, you just need to go on and do math. Don't want to embarrass yourself too much. Okay, so the title is Simplifying Radicals. We're going to look at number 1. It's the square root of 169. Okay, so somebody with a calculator, or maybe you know, maybe not, but what is the square root of 169? $13. Just comes out to 13. Okay, so this answer is 13. So we're going to write it down. It came out nice. So we don't have to do anything fancy. All right, how about number 13, the square root of 32? So somebody with a calculator type in square root of 32. What do you got, man? So it's a big, long, nasty decimal is what she's telling us. So since this one is a big, long, nasty decimal, we're not going to write down the answer. Because I don't want to write down 5 point yada, 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 yada. I'll be here forever. Okay, this one came out nice, so we just figured out the answer. But this one's not coming out nice. So this is when we do the procedure that we just learned. So we want to split this up into two possible things multiplied together. So we need two numbers that multiply to be 32. Yeah, 8 times 4, awesome. Anything else multiplied to be 32? Yeah.
6. No, sorry.
16 does divide into it.
Yeah, so 2.
16 and 2, good. So again, we have these two options, and one of them is better than the other one. But this one is decent because the square root of 4 does come out nice. This one is better, though, because the square root of 16 comes out nice, and it's bigger than the 4. So if you can think of it, you want to come up with the larger option. I'm going to do this problem a second time, but the best way is this. Okay, so the square root of 16 is 4, so you write that answer down. What's the square root of 2? Not nice, so you don't do that part of the problem. You just recopy it. So this is not a nice answer, so I just recopied it because I don't want to do it. But this is a nice answer, so I did it. And then the instructions are gone here because I followed the instructions. But the instructions are still there here because I didn't follow the instructions. Okay, so just write that down. That's the best way. But sometimes you might accidentally do it this way, which is fine. The problem is then you have to go further on the 8 because the 8 splits up into 4 and 2. And then that's 2. And then that's 4. So you'd still get the same answer, but it takes a lot longer to get there. So that's why this is the better option. This isn't wrong, but it's more of a pain. But I'm just showing it to you because you might get yourself going down that road sometime. Okay, here's number 28. What kind of a triangle is this? It's a right triangle. Yep, you're right. What else? It's a right triangle and it's, yes, isosceles, right, because it's got 2 equal sides. So as a side comment, since it has 2 equal sides, it's going to have 2 equal angles. And so they're going to be 45, right? Because this is 90. The 3 angles add up to 180. 180 minus 90 is 90, and then since those are equal, they both have to be 45 to add up to 90. Okay, so, but really what I want to know is how long this side is. So when you have a right triangle, what can you do with the sides? There's a famous theorem that goes with the sides of a right triangle. There's a guy's name attached to it. Yeah. Pythagorean theorem, right? So anytime you have a right triangle, you can do Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. I'm allowed to do that since this has a right angle. If it didn't have a right angle, I couldn't do this, but since it does, I can. So then square root of, or 6 squared is 36. 36 plus 36 is 72. Then how do you get rid of the squaring? Square root both sides, so that just gives you x on this side, and it gives you square root 72 on that side. Then what? Yeah.
Then you start simplifying.
Yeah, then you start trying to split up the 72, right? So what, any numbers over there on that list that divide into 72? 8 and 9, anything else, Emma? Or you were thinking 8 and 9 as well? Okay, so that's good. You can split up 72 into 8 and 9. There is a better way, though. Yeah. 36 and 2 is better because 36 is larger than 9. Again, this would not be wrong, just takes you longer to get there. What's the square root of 2? It's so annoying I don't even want to say it, right? So I'm not going to figure out that part of the problem. What's the square root of 36? 6, so I am going to figure out that part of the problem. Then I have two numbers multiplied together. When you have two numbers multiplied together, it doesn't matter what order you put them in. It's called the commutative property. So instead of writing square root of 2 times 6, I'm going to write 6 times the square root of 2. Same thing. Right, so that means that this side is 6 times whatever the square root of 2 is. Square root of 2 is about 1.4. 6 times that is about 8.4 or so. So that means that length is 8.4. But we don't want to write down 8.4 because that's a decimal that's nasty. I didn't say the whole thing. So we just write this instead. It's representing the length of that. Okay, thank you for listening.